All right, we're going to be looking at section 1.3 in the textbook, which is segments, rays, and distance. And the first thing we want to do is define a segment. It's defined here as a piece of a line with a specific length, meaning that it doesn't go on forever and ever like a line does, or like true love and taxes. Okay, so usually we'll have two endpoints, just like this, and this would be called segment AB. Now the difference between a line and a segment in how it's denoted is that we have a segment over it instead of when we had before, we had arrows on the end saying that that's the line. This would describe line AB that goes on forever. This describes segment AB, which does not. Next, we're looking at a ray, which is a piece of a line that has one endpoint and continues infinitely in one direction. So it's like a line that we've been chopping off at the end here. So we start at point A and we go on through point B and forever and ever and ever. And when we write down the name of a ray, we write it like this. We say this is how we would denote this figure. Notice we have the ray up top here, ray AB. Now this is very important. We do not say ray BA because ray BA would say a ray starting at B going through point A. That ray BA would start here and go through point A forever and ever in that direction. So that's not what we're looking for here. So let me just erase that real quick. Okay. So again, we have to start with the endpoint for the ray when we name it. And then we name one point that we go through. If we had another point here, like C, I could say this is ray AC. Go like that. Okay. And opposite rays are two rays with a common endpoint that extend in opposite directions. And that creates a line. And that would look something like this. We have a ray going that way, and a ray going that way, and together it makes a line. The length of a line segment is defined as the distance between the endpoints of the segment. What that means is if I have a line segment like AB from the previous problem, from the previous example, the length of segment AB is denoted like this. Notice there's nothing up top. When we see nothing up top, we're talking about length. So if I said this is 6 centimeters, I would say AB equals 6 centimeters. This is kind of the difference between saying, say this was your height and it was 6 feet. You wouldn't say you are equal to 6 feet. Your height is equal to 6 feet. So this is how we denote length. All right, some notebook terms that you have to be familiar with this year are postulate or axiom, which are statements that are accepted as true. Usually they're things that are kind of obvious to logic, and they're things that are just accepted. Okay, a theorem is something that can be proven. So we'll be proving a lot of theorems this year, and a theorem is something where we use our previous postulates and some theorems to prove that theorem is true. Now, theorems are definitely things that we have proven, so we know they're true. It's not like a theory where it's something that's not certain. All right, the ruler postulate, this is my take on the ruler postulate here, and I write it like this, that any line can be turned into a number line such that the distance between any 2 points is the absolute value of the difference of their coordinates. So if I want to find the distance between point A here and point B here, it says to take the absolute value of the difference of the coordinates. So -4 minus, because difference is subtraction, -1. Now when I do this, I say, oh, when I subtract the negative, it's adding a positive. So -4 plus 1 is -3, and the absolute value of that is 3. And you say, oh, well, couldn't I just said 1, 2, 3? Well, it's fairly easy when you have something that you can count, but when it's fractions or really large numbers, this is just a nice standard way of doing it. and the ruler postulate helps us figure out things that deal with segment addition and lengths of segments. And segment addition postulate. Segment addition postulate says if one point B is between A and C, so if I have a point between two other points, which looks something like this, and that means we could draw a segment connecting the two endpoints, so B is between A and C, then the length AB, this length right here, plus BC, this length right here, is equal to AC. Now I always like to say this means the parts add up to the whole. And most people could figure out that if this were 12 inches and this were 4 inches, that AC would be 16 inches. Most people can figure that out, so that's something that we'll be using later, except we'll have variables in here, we'll be setting up equations using it. Now, congruent. Congruent in geometry means two things are the same size and the same shape. So if we're using it for segments, congruent segments, you basically have to have the same length because they're shaped pretty much the same. Okay, so that's congruency. The midpoint of a segment is a point that divides a segment into two equal pieces. When we want to label two segments congruent, we use little hash marks here that says that these two are congruent. If I want to say in the same page or the same picture that two other pieces, I could use two hash marks to say that they're congruent, or I can say that these two are congruent, depending if I want to or not. Now, let me just get back to where we were. So the midpoint is this point right here that splits this whole segment in half. So we had a segment, and now it's split into two equal pieces. The bisector of a segment is this red line here. It's any line segment array that runs through the midpoint. So if I draw a line through the midpoint, it's a bisector. I could have a plane go through the midpoint. Anything that goes through the midpoint, it bisects it or splits it in half. And that is the end.